All right, welcome, welcome. Hope you guys enjoyed that new intro, something I worked on this weekend. It's not done yet. Hoping to make it a lot better and more professional. But yeah, cool. Thanks for joining. So what are we talking about today? We're doing DynamoDB migrations. So this is a tricky topic because it's something I'm somewhat familiar with, but I'm by no means an expert. So I came up with a few scenarios that I know can happen, and I figured we'd go through them together and see how how we deal with migrating the data in those situations. So the reason I wanted to do this stream, so someone actually did ask for it. That was the initial impetus, but with more people trying out DynamoDB, people are spending time learning it, reading about it. There is a strong focus on figuring out all your access patterns up front. So I think because of that, there is, I guess, a little bit of nervousness around, okay, what if I don't get the access pattern right? How much of a pain is it? Just because it's mentioned so much. Uh, the reason it's mentioned so much, I think there's some historical context with that. When NoSQL databases first became a lot more popular, there wasn't a lot of time put into thinking about how you model the data and what your access patterns were. So a lot of these projects ended up, being a disaster after some time passed. So I think, and because of that, NoSQL got a pretty bad reputation. So I think when DynamoDB came out, not came out, but I guess got more popular, there was a lot of focus around, hey, make sure you put a lot of upfront effort into your data model and make sure it's absolutely correct, because there's a history of people not spending a lot of time with that. Which I think is good. It's good that we shifted in this direction and set people up so they use these tools well. But I think we've kind of swung a little bit too far, where now we're a little bit too worried around, okay, if I put data in there, it's going to be that way forever. And if I make a mistake, it's not going to work. I've even heard people say, hey, if I'm a startup and I'm still really figuring out what my product is, what my data model is, and things are changing a lot day to day, can I even use DynamoDB? So I will say it definitely is a little bit more work than what you're used to with a traditional database, but it's like a lot of other things. Once you get used to the different patterns and the techniques, etc., it starts to feel normal, and you don't really think about it too much. So you absolutely can use Dynamo if you're still pretty early stage. You can change your data. You can make mistakes. There's just a standard process with that you need to follow when these things occur. And in general, there's like a spectrum of easy changes and more difficult changes. And some of that doesn't really differ too much from SQL databases. There's some changes that are easy, like adding a column, but there's other changes where, like, the way you model the data was entirely wrong and you need to kind of rebuild a new data model. It's still just as difficult. So I wouldn't say this is super unique to NoSQL or Dynamo specifically. So let me check my notes here. Um, okay, so just to summarize, like, a lot of this is going to seem hard at first, but as you get practice, it's going to start to feel pretty normal. So what we'll do today is I have 4 scenarios that I listed, and we'll try to model them, in code, and then we'll see how we deal with them. So first one, let me see. Let me share my screen. Okay. Ooh. Why am I so far up? Give me a second. Let me just adjust this. Drive me crazy. All right, there we go. Cool. So I bootstrapped, as usual, another SST project. Like the other projects that I've done in the past few weeks, this is going to be available on our GitHub repo, SST Weekly repos. I usually upload that as soon as I'm done with the stream, so you'll be able to check that out after. So to get started, so yeah, we have this article entity, the article domain, but let's do a brand new one. Let's do one called appointment. So imagine you're building a Google Calendar or some kind of other appointment, some system that tracks appointments. Of course, you're going to have some data model that represents an appointment. So let's put that together real quick. I'm just going to copy it over from the appointment entity. And of course, I'm using sorry, I'm using ElectroDB as, oh, what's going on here? As our query builder for Dynamo. If you're not familiar with it, definitely check it out. It's what we use in our starters, what we recommend to pretty much anyone using Dynamo. All right. So this entity is going to be appointment. Leave the service as that. Appointments are going to have appointment ID type string. That makes sense. Let's give them a name. It's required. And I guess that's all for now. All right, let me look at my scenario. So okay, yeah. So let me, hang on, did my stream break? No, it's good. Okay. So it's good. Let me fix these import issues here. And I guess we don't really need any functions. We'll just kind of, I guess, talk through this. So let's say this is the first version of your data model that you ship. Pretty basic, just a ID field and a name. Oh, let me finish doing this actually. Say the primary key is the appointment and we don't have a composite key. All right. Maybe we should, you know what? Let me make a little scrap function so that we can actually try some of this out. So I'll also pull up my console. That means I'm going to deploy this, which I haven't done yet. Should have prepped this earlier. Give me 1 second while I log in. Let's look at one file at a time. Just gonna make a new function here. Let's actually, no, I'll make a new function. Stack, test, handler, functions, scrap. I guess we call it scrap. Handler. Let's get the permissions in the environment in there. All right, this should let us actually use it. All right, we'll let that deploy while I talk through the scenario. So appointment. All right. So anyway, basic, basic appointment data model. So the first scenario we're going to talk about is the easiest case, where you ship a data model and then later you want to add a non-breaking change to it. So let's say you want to add another field. So let's say we're going to add a new field called, let's call this canceled. Okay, we're gonna, or no, let's call it, yeah, I think canceled is fine. Type Boolean, not required. So in the case where you add a new field, you're gonna have to go and let's say this has, actually, let's say this is required. And let's say it has a default field, which is false, because when you create an appointment, it's not canceled. So let's go through what this would look like. So when you do when you do add a new field, in this case, you might have a bunch of appointments that are already in your database, you're gonna have to go through and scan each item in there and set the default value to false, or set the value in there to false. So it's kind of similar to adding a new column in a SQL database. It might have a default value, and I think in a SQL database it's pretty simple. You just add the new column and you say, okay, default is false, and it'll make sure that that's there for all. Or you can set, I think, the value you want to backfill. But we don't have the ability to do that in Dynamo, so we kind of do that a little bit manually. So that's where ElectroDB scan functionality comes in. So for now, I'm just gonna have a simple migrate function. And I'm actually gonna not make this required because at this point, it isn't required. So we can do appointment entity scan. I need to call go. Sorry, scan go appointments. And this will give us a all of the appointments. I do think this has paging involved. The other ElectroDB functions will automatically page for you, but scan does not. Pages. Okay, we're going to ignore the paging thing for now, but note this is something I found out recently. Scan go does not fetch everything. It'll fetch, I think, 1 megabyte at a time, which is DynamoDB's limit, and then you're going to have to use the paging on it to actually iterate through. I just don't remember off the top of my head how to do that, so we're going to skip that. The other thing is DynamoDB also supports something called parallel scans. So the issue with this right now is, let's say we have like this for loop right here. This is going to be a single scanner reading. So if you have a large data set, this can take some time to actually complete. DynamoDB lets you do a parallel scan. So the way that works is you can tell Dynamo, I'm actually going to scan with 100 workers. So when you're doing the scan for each worker, give each one 1/100th of the data. So this is another thing ElectroDB doesn't support yet, but I was talking to Tyler and he mentioned that there's something he wants to add in. But the benefit of this is instead of just having a single for loop, you can do like an array. I don't know if this is the best way to create an array, but you can go like this, and you basically have multiple workers that are going to scan. And I imagine you'll pass something like the worker count and the total. So when this query goes to Dynamo knows to hash the data and give you just stuff that matches the hash for this worker. But again, for this demo, we're not going to do that. But for larger data sets, it is helpful to do that. Do note that because most likely you all have DynamoDB set on like on-demand billing. So the more aggressively you scan, the more data you scan, that's just going to cost more. For the most part, it shouldn't be too much, but if you do have large data sets, that is something to take note of. So yeah, so let's look back at this case. Let me see what my deployment's looking like. That's almost done. So in this case, we read out all the appointments, and we're gonna have to write our change here. So we want to set cancel to false. So ElectroDB will do the hard work of filtering out the stuff that we don't care about, because when you're scanning your table, you're technically reading all the data, but we only care about the appointment entities in there. So let's do a update. I can probably just pass it in like that. Can you? Can you not? Sorry, 1 second. I'm trying to see. Huh. Why does this? Let me just check something real quick. Yeah, I'm kind of confused why it is making me put the canceled field in here because it's not part of the key. It should only be asking me for appointment field. Let's see. That looks more right. That looks right also. Why does update? Oh. Something wrong with my... Let me see if something's wrong with my editor. Let's restart that. Okay, that looks more right. Okay, okay, something was wrong with my... I have to restart TS server maybe like twice a day at minimum. All right, so we can update each one. I like using this data callback to update stuff. I find it like a really good API. So you can just say, okay, I want to set the attribute of canceled to false. And then you can do go. So this will update things one by one, which again might be too slow for you. If it is too slow, you can do something like this as like a simple thing. Right, like you can just store all your promises in a tasks array. And something is really slow with my editor right now. You can get the task and then you can push the task. And then you can do like an await promise all. So this works. There are the things I'm not going to go over here are like error handling. So there's potential for some of this to partially fail and like exit out the whole thing. I like to make sure that these migrations can be run over and over without any issue. So try not to do stuff where you like append to an array or something without doing it in a more sophisticated way. Because then if you run it twice, you'll end up with 2 items in the array. For something like this where you're just setting an attribute, it's probably fine to just run this migrate. This is like kind of already idempotent. People have built like more sophisticated versions of this where this will actually get executed as... Sorry, my cat has been going crazy. This will get executed as a step function where each one of these updates execute as its own lambda. But again, you can start simple, just write these migration files, get comfortable with this, get used to the different patterns that show up. Then you can think about how to make them run faster and more efficiently and more safely. So as a base, this makes sense. It looks like our thing finished deploying, but it might have not picked up this new function. So let me just make sure. Yeah, let me run that. The console. It's bigger. Pull up our table. Oh, there's nothing in here yet, obviously. Okay, so what we're going to do now is we're going to make a bunch of the old appointments, run this migration script, and see how it works. There is a case that we actually haven't covered with this, and I'll explain that in a second. Man, my cat is screaming. Waiting for this to deploy. All right. Function is here. All right, so let's go to our scrap and let's did I export this? Yeah, I did. Okay. So appointment entity create appointment ID. And let's create. So again, this first example really contrived, but it'll help us get this setup going so the next few are less crazy. So let's create 100 of these. Oh, async. Let's invoke it. All right, what's the issue? Handler not found. I didn't export this. All right, I created 100 of them. So now we have this data in there. Cool. You can see it. It's all in there. It's missing the canceled. Well, it's in there because I set the default already. But let's take this out and run that again. Although I'll need to delete all these. Let's see what's the best way to do that. I guess I'll do a quick truncate function. Okay, scan. One thing that I wish Dynamo had was the ability to delete a whole partition. You have to delete each item one by one, which kind of sucks. It doesn't really matter in practice, but when you're doing stuff like this or like test environments or mock environments, deleting stuff can be a bit tedious. All right, let's run this again. All right, let's make sure the default didn't get inserted. Okay, cool. So we now have our data, and now we're going to migrate it to the next thing. So if we go back to this, I'm actually just going to move. So we're going to update the code there to have the new field, and then we're going to run this, which will hopefully migrate the data. Scan, go, update, appointment, set canceled, false. Yeah. Run this. Okay, cool. So now we see, okay, all these appointments have the cancel field. So it's obviously the easiest case. We don't have to really worry about too much. We can just add the field and things are going to be fine. There is one issue that we didn't consider. Technically, if we are running this migration before we've deployed any of the new code, there's a possibility for new appointments to be inserted while this migration is happening. So this migration might pick up 100 appointments, but it might miss the 5 appointments that were added after the fact. So like as your migration was running, things could be inserted, and the scanner might already be past the point where the things were inserted. So that's the one thing you need to watch out for. The way to deal with that is, this is where it gets kind of annoying. I think the technically correct way to do it is you make the code change first. So you deploy the code that just has this new canceled field with the default set to false. This will make it so any new appointments that are created have the right value. So at this point in production, you have some appointments with the canceled field, some appointments without the cancel field because they were from before you deploy this change. At this point, you should not deploy any code that depends on this field existing because you have a partial data situation. Some data has it, some data doesn't. But once it's deployed, you'll know that any new appointments will definitely have this field. Then you can run the migration, which will then populate some of this stuff. Again, this is maybe less common in SQL, but there are situations in SQL databases where you have to do this as well. So there's like this pattern of deploy code change, run migration, and sometimes deploy another code change to like remove some of the old code. That's a pattern you're going to see pretty often when doing data migrations. The other thing is like everything else in engineering, it comes to your judgment call. You can make the call that it's actually simpler to run the migration a few times than like do this whole dance. If it's data that's not getting written to that often, or you're running the migration during a time where there's not that many people using your application, you can run the migration multiple times and potentially get everything. So yeah, I think if you talk to some people, they'll say, well, that's not technically right. But again, my point here is DynamoDB works for, small projects, startup projects. You can be practical about some of this stuff. You don't need to do things absolutely perfectly every time. So quick question, does DynamoDB client support 08? So we're using ElectroDB for the DynamoDB client. So it does support async await. And I'm pretty sure just a straight up AWS SDK clients, both V2 and V3 support async await. Let's see, Lucas. Share the code at the end, please. Yes, I definitely am going to share this code. Thoughts on lazily applying the default value on read for a new non-primary key attribute? Yeah, so that's actually a clever thing to do, right? You can leave partial data where some of the data has doesn't have this field set, and some data does, and whenever you read it, you can load the false value there. So that's like, I think the benefits of that are it's a pretty easy migration. There actually is no migration, right? You just deploy the code change and you're fine. Your application layer is filling in the gaps there. The one reason I don't love that is I think when you have that approach and you do it over time, a lot of these things start to stack up, and the data in your database starts to have, they start to look different from each other. Each item in a collection starts to look different from each other. Like some might have, the older ones might be missing a few fields, and newer ones might have a lot of fields. And over time, this can get kind of tricky to manage, especially if you're syncing this data into another system. So for me, I always connect Rockset to Dynamo so that all my Dynamo data is also in Rockset, available for querying, analytics, whatever else you need. And now Rockset kind of has to deal with that complexity where you have partial data here and there. The approach can make sense. It comes down to, like I say all the time, it comes down to what you're doing and whether that's an acceptable trade-off for you. But for me, I found having consistently reliable database data at the core of my system is usually worth whatever cost it takes to maintain it correctly. Yeah, Alex is saying recommend that only for larger tables or migration, a bigger pain. Yeah, sometimes your tables might get so large that running a migration has like a significant dollar value or like a time cost or just like a risk of something going wrong. So then it might skew it in the favor of maybe fixing stuff in your application layer. I think I'm generally okay with defining stuff in the application layer. Like if you look at this schema, this whole schema is defined in the application layer, right? Because most entry points to your system are through your application. They might come through your API. They might come through like the domain layer that that we have set up in our SST projects. So typically you can pretty much guarantee that your application layer can massage the data into the right format. There's just some cases where sometimes things talk directly to the database and skip your application. This is actually one of the reasons why I like having a domain layer. It lets you control more of that. I think a lot of people using AppSync plus VTL or just VTL in general will talk directly to Dynamo. You have less ability to control those things in a centralized place. So yeah, I think it just comes down to your overall architecture. Okay, so in this case, we finished this first scenario. So all our data in our database was consistent. Cancel field is true. So now let's move on to scenario B. So let's say we realize, this is a very classic thing, this field canceled, which I thought was binary, either can be true or false is actually can be in multiple states. It turns out it can be canceled and rescheduled, or canceled permanently, or not canceled. So you're realizing, okay, a Boolean is not the right way to model this. We need to model this as some kind of enum, right? So the challenge here is if we do the same approach, it's going to break some existing code, right? If we just run this migration and rewrite all the data to be a string enum instead for this field, any code that's out there already running, because you haven't deployed it yet, any code that's expecting a Boolean is going to break. So this is I consider a breaking change. It's a little bit harder to implement than the previous one, where it was an additional field where no existing code was already depending on it. So the thing to think about here, again, use your judgment. Sometimes a breaking change is okay. Like maybe you do the migration and deployment happens. You can like confidently say deployment is going to happen a few minutes later. It's okay. There's a few errors at that time. Maybe a more sophisticated migration is not worth it. You don't have to obsess over, again, doing it the exact right way. And it's kind of the theme of this whole thing, right? You're going to make mistakes. Even if you're spend all the time doing your data model absolutely correct, you think through all the access patterns, your business is going to change. There's going to be new information that shows up. You're not going to get everything right on the first try. So a big part of your job is to make it so making changes is easy and you know how to make changes when things go wrong. And you don't have to like get everything perfect every single time. And this is another example of that. Like it's okay to do a breaking change if you feel the impact to the users isn't too significant. So I just want to point out there is one option that would make this not a breaking change. You can make this a new field. So canceled next or something. And canceled, rescheduled, not canceled. If you do it like this, then this goes back to being like scenario A. You don't have like you're just adding a new field. No existing code depends on this. And this again is a valid approach, but this goes back to what I was saying earlier, where this becomes like kind of a non-ideal field. You're just kind of putting it in there to avoid the breaking change, which again can make sense. But again, over time, you imagine you have a lot more of these types of things where these things start to add up and your data model looks a little bit ugly. It may be worth doing like a cleaner migration where you get rid of all the old data. So in this case, ElectroDB actually provides something that is pretty useful that we can use. So if you look up here, there is a concept of version. I've actually never used this before, so we're going to try it live and see how it works. You can make different versions of your schema, and the versions will be completely separate. So if I do version 2, if you look here at the primary key, you see how it has that 01 in there. I believe that's a version number. So anything new under version 2 will be all brand new data. So the benefit here is it's kind of like this, where you have like a new field, so it's not as much of a breaking change, but you can do it in a first class way. So I haven't done this before, so we'll see if this ends up being something we like, or maybe it sucks and we don't want to use this that often. So we have our new entity. So we're going to call this entity 2. And everything else is pretty much going to be the same, except this cancel field. I should have saved what I had earlier. Did I save what I had earlier? No, I didn't. This cancel field is going to have canceled, not canceled, rescheduled. Not canceled. Okay. So now we have 2 schemas that represent the same data. So if we go back to our migration file, let's see how we're going to do this. So we're going to keep the same, like this part is probably going to be the same for all your migrations, right? You're always going to be iterating over some entity. But in this case, we're going to use appointment entity 1. And we're going to create, let's see if we can just do it like this. Can we just do it like this? Oh, no, we can't because... Okay, so this will now create a second copy of all your data that will exist alongside your primary data. So when we run this migration, nothing's going to break. Everything's still going to be reading from the old data. You still have the issue of new things being created as your migration runs. So what you want to do here is if you have domain code that's like create appointment, you want to write to both for a while. Write to 1, or I guess, was it 0? That was 1. This is 2. Okay. Write to 1 and write to 2. Let me rename this to 2. So you deploy this code first. So at this point, writes to your database will be generating twice the amount of data, which isn't ideal, but it's a temporary thing. So you'll be writing appointments in the new format and then also in the old format. So we're not going to actually do that because it's a little bit hard to demo. But once you do that, you don't have to worry about new data being inserted that like as your migration is running. So you'll be writing it in both forms. I guess this needs to change from a create to a put because it could already exist because it might be something that was written after the code was deployed. But then, yeah, you can run this. And let's do that now. Canceled. Oh, I guess it should be not canceled. Canceled. Okay. So we can run this now. All right, now you can see we have matching appointments for appointment 1, for appointment version 1. If I'm looking here, it looks like, oh, interesting. The version got put in the sort key. That actually makes sense. So I was wrong when I said the primary key had the version in it. It's a sort key that has the version in it. Yeah, that makes sense. So basically for each key now we have 2 values, appointment 1 and appointment 2 with the new format. So at this point you have run the migration. Your production code is still writing in 2 places, but now you can roll back your production code to make it to get it out of its temporary state. So what you'll do here with your production code is you can now remove the old appointment entity. You can rename your new appointment entity to being the old one. And then you can remove the code that writes to 2 places and make it write only to 1. So at this point, when you deploy, all of your data will just be referencing appointment version 2. And then I'm realizing how complicated this is. So I actually should not have deleted this. I should have swapped them. Appointment. So this is appointment 1. Or hang on. Appointment entity 2 becomes appointment entity. And appointment entity 1 becomes appointment entity 1. And then we can go to our scrap, which is our migrator, and then iterate. So once we verified, okay, everything looks right, we can clean up the old data. So this is something you don't have to do right away. Again, this goes back to what I was saying earlier about keeping your database clean. I think you do want to eventually get rid of it. Do you have to get rid of it right away? No, I think you can leave it in there for a couple of days. Make sure that something in the migration didn't go wrong. If it did, you always have the old data to reconstruct or fix whatever you need to fix. But if you are ready to delete it, we can kind of iterate. We can iterate over them. And delete them. I think that should be it. Let me just double check. This is the right version. It's going to delete 1. Okay. So if we run this again, it's running and we go to our Explorer. Okay, you can see now all the appointment 1s are gone. We only have appointment 2. This is also reminding me, we want to overhaul this DynamoDB Explorer. I think right now it's built as like a generic explore any table type of thing. But because we're like pushing ElectroDB and a lot of people are using ElectroDB now, I think we can like scan your code and pull out all your ElectroDB data models and structure the UI around that. So instead of just like a single table, you can have maybe a tab for each of your entities. And instead of a table with where a column for every combination of attributes you have, it can be very focused around the specific entity. We can provide, because in ElectroDB, you also name all your access patterns. We can provide like easy queries to query your different indexes and query these fields by name. So I'm pretty excited to do that. I think it'll make DynamoDB a lot more usable. I believe Dynabase kind of already has some of this feature. I know they have like a single table mode where you can teach it your single table schema. But everyone does single table a little bit differently in terms of how they format their primary keys and how they format their sort keys, all that stuff. And because ElectroDB has a pretty good opinionated way of doing that, we'll probably just support that format, and it'll probably be useful for a lot of people. And I think, again, it's another great reason to use Electro. Okay, so just to jump back. So we've now finished scenario B. We've changed one field from one type to another type. We created a new version of our schema, copied all of our data into it, then cleared out our old version, and then now we only reference the newest version. All right, now we can move on to scenario C. So this one is probably the most complex, and let's see if I can even do it. Okay, we can delete appointment 1 now because we've cleared it out. Another great reason to use TypeScript, so you'll be notified of wherever old code needs to be deleted or modified. Okay, so let's say, so in this data model, we set the appointment ID as a primary key, which makes sense. Like we were just thinking, okay, we have an appointment ID, we need to fetch the appointment, fetch it by primary key. And then we realize, oh no, we don't have a way to list all of our appointments. So this is, I wouldn't say common, but you can imagine this is like a example of an access pattern mistake. You knew you had to get an appointment by ID. You maybe didn't realize you needed to be able to list all your appointments. And this is scenario C, and we have kind of related scenario D. And some of you might pick up on what I'm going to do wrong in the next phase. But we realized, okay, we need to add a new index where we can list all the appointments. So how we go about this? So we can think about, so in this case, this is kind of a non-breaking change, right? Because we're just gonna add a new index, we're not gonna change anything existing. So we're gonna add a new index called list. It's not gonna have a primary key, which is that allowed? Let's see if it's allowed. And it's gonna put, I guess this field needs to be GSI1 PK. So in the first global index primary key, GSI SK. So the composite will be the appointment ID. Okay. So if we just start using this and we go here to implement like a list appointments function, the challenge here is if we go here, do query list, go. What does this need? Okay. You'll expect to get a list of appointments, but it's actually not going to work because you never wrote to this index for all your existing data. You now need to rewrite your data to make sure it gets picked up in the index. So if you look at these objects, right, there's nothing in the GSI1 PK field or the GSI1 SK field. So you're gonna have to basically rebuild your index. In a SQL database, it actually does the same thing, I believe. So if you go and add an index to a column that you didn't have an index on before, the SQL database will do the work on your behalf of going and iterating through all the rows in the table and building the index. That's why sometimes creating an index in a SQL database can be really slow, because it's a huge table, you need to recompute the index for the whole thing. I do believe some of them let you do that asynchronously, so it'll unblock you, but the index building will happen on its own. So again, it's kind of what I mean by ultimately all the techniques are pretty much the same, all the scenarios are pretty much the same. SQL database just handles a lot of this more for you automatically. which is, one of the benefits of using one, and it can make sense to choose that. The thing to remember is this stuff feels complicated, and it is complicated to some degree, but eventually you start to build patterns and tooling around these things. Even me going through this now, because I've never actually done this this rigorously with a bunch of scenarios and really thinking them through, I'm realizing we should provide, I mean, this has come up before, but just kind of some migration tooling for handling some of these scenarios. I don't know what that's going to be yet. I think I need to become more of an expert on this stuff before I can do that. But clearly something can exist, like some kind of migration framework for some of these situations can exist, especially if that can be deployed using like serverless technologies too, right? If you can use step functions to coordinate all this, it actually is a good use case for that. All right, so in this case, we need to go and pull our data out and basically rewrite it. So we go through appointment entity. Let's see how to do this. I actually wonder how this is going to work, because appointment entity is appointment ID is read only. Is there a way for me to do this? Okay, let me remove the read only for now. So if we read everything out and just put it back in, is that all we need to do? What happens if I put this read only back? It should complain. Oh, it's not complaining. Maybe puts don't care. It might complain at runtime. Let's see. So we're gonna read all the data out and rewrite it. There's probably a better way of doing this, like a more efficient way. Like instead of rewriting, like this could be a huge object. Like you really need to put in the whole object back, but this probably works for now. Duplicate index. Oh, this is our GSI1 index. Should be able to just rerun that. Okay, that seemed to have worked. So let's look at our data now. Okay, yes, this did work. All right, so now we have this data rewritten with, and we've kind of hydrated this index that didn't exist before. So this scenario, it seems like a severe scenario. You messed up an access pattern, but you can see how remedying it actually was easier than some of, like the previous scenario was actually much harder because that was actually a breaking change. So like some of the stuff is counterintuitive. Sometimes access pattern changes are easier than simple field mistakes. So of course you want to do your best not to make these mistakes up front, but if they do happen, it's not the worst. Okay, cool. So now the next issue. So it's the final scenario. So I'm combining some other thing I wanted to talk about as well. So this is an interesting data model because in the primary index case, we're building this in a very scalable way, right? Every appointment gets its own partition. That means if you have like 100 servers and 100 appointments, your appointments can be spread evenly across those servers. If you have 1 million appointments, even then it's going to be spread pretty evenly across all of those servers. So this is a good data model in terms of it being scalable. But now that we have this index, this one is not super scalable. So the appointment ID, so we've created a partition where there's actually only one partition ever. So if you have 1 million appointments, they're all going to be in the same partition. There's going to keep getting appended. Every single sort key instance is going to get appended. So you might find over time that this actually is not performing really well. So this is another mistake. I think I've heard different ways of phrasing this. I've always heard this as a hot partition problem. That's like from my Cassandra days where you'll have just, so if you have 100 servers, it doesn't matter if you have 100 servers, all the data for this index is on a single server. You can double it to 200 servers, 1 million servers, it doesn't matter. Like, yeah, the data will get replicated and that eases some of the burden, but it can't scale totally linearly with number of servers you add. Or not linear, just one-to-one with number of servers you add. So this can start to degrade in performance over time. And this is another very classic mistake that happens. Again, you don't have to worry about this stuff super upfront, right? If you know your business is only going to ever have 10,000 appointments per year. Is this a severe issue? Probably not. I actually don't know at what point the hot partition stuff will show up, but I doubt even at like a million scale, it's really going to show up. I think it comes down to how many, like, if you're reading that a lot, like all the reads are going to go to that same partition, so that can start to bog it down. But again, like, you don't have to worry about this too much up front. Be aware of how it can happen, so you know how to get out of it later. But so you're not surprised. But again, you don't have to obsess over it up front. So in terms of how we can fix this, so I've always called this synthetic sharding, but I've heard it as sharding, by the way. Everyone just laughs whenever I say that. I gotta find a different name for it. There's other ways of doing the same thing, or there's other names for the same thing. But the idea is you create a field called shard with a D. Say this is just a string, and it's going to be required. And I think ElectroDB has this cool thing where it can watch another field, but I'm actually not going to do that for now. I'm just going to do this manually so you can see how this works. So the idea with the shard is you give a way to split up this index. Let's call it shard ID so it's more clear. So then you can give it a primary key, shard, and then this way you can split up this index into a fixed number of partitions. So you can say, okay, in general, I'm going to want 25 partitions, so at least this data can be split up 25 times. So if 1 million was your limit before, you set it to 25 shards, now your limit is 25 million because each shard will only contain 1 million and you'll have 25 shards in total. And if you want to list it all, it gets a little bit trickier. You have to, in parallel, query all of your shards. But you know them ahead of time, so you can just send basically one request to shard 1, one request to shard 2, one request to shard 3, etc., and then collect all the results together. And you can do that in parallel. This is a pretty effective technique in keeping Dynamo pretty scalable, even with large data sets. You basically are breaking up the query into n number of steps instead of just doing one single step. It's actually not too dissimilar from that parallel scan thing I talked about earlier. Cool. So now we have this issue of, okay, all of our data is written to a single shard. How do we get it distributed among multiple shards? I think this probably is a breaking change because you're going to have data that you're going to have code that's referencing this initial index before we changed it. So we're probably going to want to make a new version again. So this is appointment entity, I guess 3 now. Appointment entity 3. Let's add this shard ID. And let's do a primary, let's do the list shard ID. All right. Okay, so we have this version 3 now, and now we need to read all this data out and rewrite it on the shard, so we rebalance it. Again, you have to do something similar to before, where you're writing to both version 2 and version 3 at the same time. You want to deploy that up front, so new data is being written in the new way ahead of time. And your migration script is less of a migration, more of like backfilling the old data. So let's go to scrap. Let's see here. So appointment entity 2, or I guess this is 3 now. Well, I guess we're still reading the current one, and we're gonna put it here. And you can see we're getting an error because we're missing the shard. That error is unreadable, but we know we're missing the shard. So the question is, how do we compute the shard? You want to compute the shard pretty much based off of the appointment's ID, like the thing that does not change at all. It represents the ID. Trying to think. Let me just pull a hash code function from another code base that I have. One thing I hate about JavaScript is I feel like the standard library is not very good. Generating a hash code from string really should be built in. Whoops. All right, so this is the hash function. So this basically give you a random number, a deterministic number based off of a string. It's not going to be perfect, right? You can't map any string in the universe to a specific range, but that's fine because we're not using this for uniqueness. So we can hash appointment ID. So give us a random number, and we're going to mod it by 25. So I guess I made this a string, which is fine. So what this means is it's going to get assigned a random shard based off of the appointment ID, and it's going to range from 1 through 25 or 0 through 24, I guess. And this should work. So we're going to write the data in the new format. Let's run this. Okay, that worked. And we'll see if it's there. Cool, appointment 3. And you see there's like there's a different shard for each of these. 3, 3, 23, 2, 19, 2, etc. So this hash function isn't perfect, right? It's not going to perfectly balance everything evenly across all 25 shards, but it's going to be pretty good. I think with enough scale, you'll see law of large numbers. You'll see roughly evenly balanced across all 25 shards. And then we can go and we can clean up. Because we can go, if we follow what we did last time, we made this the old one, made this the current one, and then we ran a delete on all the old stuff. Appointment 2, all right. Is this gonna work? All right, cool. We got rid of all the appointment 2. Cool. Now if we look at our index, we can see that we have all these 25. Well, we can't see them all here, but these 25 primary keys or 25 shards. Real quick, I'm going to show you an example of how to actually query these. So in our scrap, we basically want to do parallel queries. So we'll do this array fill thing again. And I don't know if there's a better way to do this. So here we can now do appointment entity query list, and it's going to require you to pass in the shard because we defined it that way. Turn this const results. Yes, these are tasks. Console.log await promise all tasks. All right. So basically what this is doing is it's going to kick off 25 parallel queries to each shard and concat all the results together. Well, I guess I want to flatten that. No, we want to flatten that. Kind of ugly, but that works. So let's run this again. Okay, so see that was pretty quick, even though it queried 25 shards. And we have all the things here. I think if we did all our migrations right, this should be 100, I think. Yeah, nice, 100. So again, not a lot of data, but you can see how there's really practically no additional cost to another shard in terms of reading. Like even if this is 50, it's probably going to come back in roughly the same time because kicking off 50 network requests isn't that much work. It's probably going to be a little bit slower to come back, but you have to benchmark and see because Dynamo might return faster, even though your network coordination is a little bit slower. So it's a technique. I think someone was mentioning this in our Discord. It might have been Tyler recently. Yeah, again, I call it synthetic sharding. I don't know if there's other names for it. Again, it's another example where this is like an issue you ran into because of scale, and there are ways to rework your data for it. Of course, a lot of this is going to be harder. This is like a contrived situation with just 100 records. If you have 1,000,000 records, these migrations are going to be slower to run. But the techniques are still going to be the same, just a judgment around when you run them, when it's worth it, when is it better to leave old data in the database. Like that's what's going to be affected. But in general, these cover, I don't think these cover all the scenarios, but I think they cover some pretty standard scenarios. So again, to reiterate, scenario A, there's just adding a new field, pretty easy, no breaking change. Scenario B, that was a breaking change, renaming an existing field to something else. Scenario C, reworking an access pattern. So again, this is something that seems scary, but in this case was not too bad. Just really building a new index, which was not a breaking change. And scenario D, this is an access pattern issue plus a breaking change, and we're splitting it out to multiple partitions. Yeah, so it's all the scenarios that I had. Like I said, I haven't actually run through this rigorously up until this point. I've had to do migrations before, but didn't like do them so meticulously. It's not that this was that great to begin with, but it was helpful for me to kind of run through this and see how you do it all in Electro. One of the things I'm taking away is this is a lot easier with ElectroDB. Like even just the ability to do this. So this scan is actually very useful. If you're using straight DynamoDB and you're trying to scan your whole data set, building these complicated partition keys are important for single table design. Building them yourself and like filtering out data, it is pretty tricky. So it's nice to have something where it feels like, oh, I'm just iterating over the specific entity on the table. So I think ElectroDB makes a lot of stuff easier. I think we're gonna have to figure out some patterns around some of these common situations and either provide example code or a library or some kind of solution. I've seen this come up a lot. No one's done it yet, so I'm assuming it's pretty difficult. So maybe it's not realistic, but we'll see. And then even just running the migrations themselves, right? Like I was just using this little scrap function. I think there's probably different ways to go about this. If you look at our RDS setup, we have an SST script that runs your migrations, and each migration is defined as a JavaScript file that just runs. There's actually no reason you can't do something similar with Dynamo where you just have a directory of all your migrations and you have a function that runs them, maybe a function that undoes them too if you want to support that. You can keep track of what migrations you've run in your table, and your script can iterate through those and just run all the migrations that have not been run. And if they fail, it'll bail out and not mark it as completed. So we could probably provide something for that. Like when we have that in our RDS side where you have all the migrations, you can run different ones. It might make sense for Dynamo as well. But yeah, so that's all from me. I'll hang out for a minute, see if there's any questions, but yeah, take it from there. Okay, doesn't look like we have anything. Still a check. Cool. Well, thanks for joining and hope this was helpful. Yeah, I think it's something we should just keep talking about in the Discord. I think as some of our projects get more mature, we're going to rerun into situations, and I'm sure we'll kind of collectively come up with some good ways to do some of this stuff. All right, that's all for me. Have a good rest of your week, everybody.